Hi everyone, again thank you for joining us today for webinar 29 in the series. So today's topics, we're going to be looking at the COPA roll scanner, its link to the RLM, COPA RF design, and the synergy between our individual solutions. Our roll lifecycle management tool, taking scanned rolls so that they can be loaded directly into an existing roll design made with COPA RF. Then we're going to look at the regrind functionality, the regrind roll functionality, and how fast that and easy that is to calculate how much the roll contours need to be reworked to make them usable again with a worn roll. And then assembly check, a tool whereby the position of the individual roll is cast onto the roll design itself, and then the result forms an actual assembly on our screen. So this helps us with quality inspection of worn and of course new tooling more so. So now let us consider roll lifecycle management. It's a closed loop roll management system with the COPA RLM, and we encompass everything from design and simulation, order processing, stock management, production of our tooling, and of course our quality control. And you can sort of see the facets here within our chart to give us total transparency in the design, manufacturing and production of our new tooling and profiles. So of course now we must consider how we will get our roll contours into the RLM database. So first of all, if we consider our geometry from the COPA roll scanner, this is transferred as scanned rolls into the RLM. And then from our COPA RF design suite, we transfer our rolls and our design into the RLM as well. What we're allowed to do from the RF design suite is collect the scanned contours and then load them in our design. What the RLM database does, it stores all of our designed and scanned roll contours in its algorithms. And this allows continuous monitoring of roll wear and roll quality, and that's the key. So let's consider how we transfer existing rolls into the COPA RLM. So we take the COPA roll scanner, and the interface provides an easy transfer of tools without any documents. So if we don't have anything, any legacy data for the rolls, maybe it's from an external supplier or from pre-electronic times. We can scan existing rolls and transfer the measured contours directly to the COPA RLM database. But then it's important to remember each roll can have multiple scans. So whether these done periodically or annually to look for wear. And just so you know, there's more information upon the COPA roll scanner on our website, sort of with regards to specifications, sizes and geometry of roll that can be scanned. So you can see a link there, something you'd like to look up at a later stage. So if we'd like to transfer our roll designs now to the COPA RLM, this has to be done in order to make use of the COPA RF regrind roll and assembly check functionality. An existing roll design has to be transferred to the RLM database. There are different possibilities to do this. We can import the scanned contours from the roll scanner. We can import from AutoCAD drawings, DXF files for example, 2D geometry. Of course these can be exported from SolidWorks, Inventor and so on and so forth. And clearly we can import from existing COPA projects directly. So let's just talk about some of the benefits of the regrind roll tool. So without the COPA roll scanner and in COPA RF, it can take more than 100 engineering hours to determine the regrind contour of a worn roll. This could be done with a CRM, a Roma arm or something similar. Okay, so let's consider that now with the tools that we have. With an existing COPA roll design, the regrind contour can be instantly defined. All we have to consider there is the required time is about 5 hours to scan the rolls into the RLM. So when having the roll designs only as AutoCAD drawings, the rolls need to be transferred to Copra. Sort of worst case, we can imagine this could take up to 3 hours. So then if we have no design data whatsoever, the tooling needs to be re-engineered from the scans, in which case we could add a further 8 hours to that. So if we add that up, it's still a significant saving overall to estimate the regrind rolls than using the sort of standard methods right now. One other thing to consider, as a roll wears, this can also show us potential for a design optimization. So if we're seeing where a roll is being worn continually, in other words, it's a repeat roll, this gives us a sort of an understanding that it's something we could look at also in simulation. So this is something we can sort of pick up more easily when we're looking at the regrind requirements of a tool. So now let's consider the assembly check functionality. So first of all, some of the individual steps. The roll tooling designed with Copra RF as standard. The rolls are manufactured and they're then scanned with the CRS for quality purposes. And the scan contours are directly transferred to the Copra RLM database in the same way. And then in Copra RF, the designed and scanned contours can then be directly overlaid and compared with each other. So again, some of the benefits of this: any problems with roll widths or with forming radii are immediately visible. The first roll will be aligned with the machine side. All rolls following this will be aligned to the previous roll. And a setup of multiple rolls with tolerances accumulating could easily lead to a wrong position of a bend zone. And we can see this directly on our screens. And of course, one of the key things to consider, any roll modifications made during setup and verification, they'll also be visible. And this is quite often where organisations are unable to track changes made at the machine. So when rolls are manufactured at a later stage to replace the worn or lost or broken tools, maybe they encounter production problems at the machine again because the data, the modification data, hasn't been captured. So this means the tooling design can instantly be updated. So that's a key thing, of course, for production companies. So here we can sort of see some of the detailed information about roll positions in the assembly. It shows the offsets in the positions due to the deviations in roll widths, what's required to make this assembly suitable again. So for both tube designs and profiles, the software supplies detailed information about roll positions in the assembly, showing offsets in the positions due to deviations in the roll width. And here you can see in magenta, this is the design contour, our desired contour. And then we have in red the scanned contour, the actual position, the accumulation. So here with this example, you can see we're no longer in the position to form this profile. Then what we have is a suggestion, the reworked contour, what's required for us to manufacture this, this profile, so how the roll should look. And then when we consider the recutting for tube rolls, we can see the diameter reduction and how this is easily defined. So you can see again here in magenta the design contour, and then in red the scanned contour, the actual roll itself, and then of course the rework contour, what needs to be done to the roll to make it usable. So I have a demonstration of how this all works now, so if you just bear with me a few seconds, I'll just prepare my screen. Okay, so you should now all be able to see my AutoCAD screen with a tube profile on there. So what I will do is I'm just going to open some sizing rolls I have scans thereof, so bear with me 1 second. So now we can see our scanned roll geometry. So I just need to do a little bit of work to this polyline. and now we can see our geometry. I managed to lock the layer there, sorry about this. So now we have our complete roll contour, so I'll copy this information from here into our design window. We just put that over to there. So now this was for station 22, so now I'll move across to the station 22. Now you can see I've already taken these rolls across into the RLM database because they're orange. So these are database rolls, okay? So now I have a command here, so import scan contour into RLM database. So I'll just click this icon and now I identify the roll, so it's 22B1. And then you can see over here the dialog pops open. And now I have to specify the start scan import. So I click that and it's asked me to select the polyline for the scan. And then we can see immediately the polyline's been overlaid here. Okay, and then I'll just save this. And now we're able to switch between the design and the actual roll. So this is now comparing the information from reality to design. So we can see this roll has already been recut. So if we need now to clean this up, we can now move across to roll utilities, and this time we'll use the regrind function. You can see as part of the calculation it's looking at the stations when these aren't completely on the axes. That's okay. I'll just close this dialog over here, and now we're able to see, I'll just move the dialog over here. If we scroll down to station 22, the bottom axes you can see here that right now we're at a 0.55 maximum deviation on a radial. So if I, for example, update this, a little bit too much, you can see here the scanned contour is in green, and because we're now working on the side of the tube roll here, we can see that that's going to be insufficient. So now I can actually use the wheel mouse and move the contour down so I can be 100% sure that it will clear up. You can see here the scan contour heavy, the radius has left the roll there. So now in this example we can see there's a 0.9 drop in diameter to clear this roll up. So while we consider rolls clearing up, let's look at an open profile now, and we can take the example of a roll that's been modified. Now I've already imported the scans here, so if I just do a recalculate, I'm going to look at station 11 because I'm aware that here for the top axes, in this example we can see our scan contour and then here is the scan contour and then our new contour. So to get this to clean up, we should see a much higher value appear now. The new contour of the roll is invalid. So we can see in this example now, which would be an indication that the roll itself has been modified at the machine. So for this geometry to clear up here, we would need to reduce by 6 millimeters. So in doing so, you'll see that now our design contour, which is this contour here, will get a fresh cut here on roll top. And it's quite clear this roll has been modified here at production. It's been cleared away in this area here. So as we don't want to reduce the diameter by 6 millimeters, as we would need to get a sort of a fresh clean geometry. I mean, you can see here this is a scan, sort of the worn check on the roll and then the cutter radius here. What we could also do now is update the Copra design itself to make sure that the design then reflects the scanned roll. So in this example we could modify the roll with smart rolls, for example, to make it match the scan contour. And then in which case there would be a much less requirement to clean up the geometry. And now finally, what I'd like to show you is the sort of the regrind assembly possibilities, how assembly check works and how we can view the accumulation of tolerances. So I'm just going to select this simple C section again, it's open profile. I'll conduct a new calculation. And we can see here now in station 7 we're highlighted, and our bottom axes first of all. So let's switch back to station 7. So again we can see our scan contour. And now here we can see the new contour. So this is the designed roll, and then there's a scan that we have here, so we can see the flange is much wider in this respect. So there must have been a problem at manufacture somewhere, and we can see then the new contour, this orange line here, what's required to make this roll function. And what's happened, you can see here, to make this meet along this area, this bottom roll has also been reduced. And of course over here you can see on the right hand side. Now if we just align here with the assembly check tool, what the assembly check mode does now, this actually aligns all of our scans adjacent. So previously they were stacked. So now you can see they've all been assembled. And now we can see if we were to take these rolls to manufacture at the machine, we would have quite a significant gap between the flange and the strip itself. So we can imagine there would be some malforming going on there at least. So you can see what would be required again here by the orange marker to make a good recut of the rolls to allow them to work in reality. And this would give us a good fit then of the profile when it's sort of in this situation. Whoops. Like so. And of course the top roll would move down. We can see the same here of the top roll. There are some variances between the roll here. So again you can see the culmination of tolerances which has resulted in this position here. So the orange contour, of course this could give us some serious problems in this radius. The orange contour here is the recut contour, what would be needed to clean up the roll and give us the geometry we require. And what I'd also like to mention, this along with all of our other new and exciting features for Copra RF 2017 are available in the release notes, and you can find a copy of these release notes in your install folder, and an example here would be in C Program Files Copra 2017. That's where you could find the sort of the English and the German language release notes. And it's also worthwhile mentioning that the Copra RF 2017 updated workbook is now available. Unfortunately, it isn't part of the install. However, it's available via the online info center directly via Copra RF 2017. Or you can also see a link here where you can link to it directly from your web browser. Now I should also let you know that you can see the roll scanner itself in action at Euroblec in week 43. You can visit us at our booth G142 in Hall 27, where we'll have a roll scanner and a team of experts on hand to show you how this can work in reality, along with all of the latest new Copra 2017 features and functions for you to road test and discuss with us there. And that's between the 25th and 29th of October in Hanover, Germany. You can find out about all of our latest product releases, our exhibitions and seminars we're hosting from our Twitter feed, as well as the DataM website, and you can follow us there at DataM SMS. All of our recent product videos and information can also be found on our YouTube channel along with our website. And again, a lot of our company and employees are also on LinkedIn if you'd like to connect with any of us on there. So that leaves me to say thank you for your attention, everyone. I hope this has been informative. Now you can see the true synergy between our roll scanner and Copra RF 2017, and of course some of the time-saving functions and features it has with sort of the regrind and assembly check functionality. So it leaves me to say have a good day, and again thank you. Goodbye.